Hello everyone, my name is Benjamin Gansa and I'm presenting on generating high resolution crop canopy height information using SkySat Stereopair. Accurate high resolution crop canopy height data are useful information in predicting yield for crop production. Traditional method of canopy height estimation are labor intensive and time consuming. While UAS has been used, they are limited in coverage and require consistent calibration, and therefore are limited for large scale applications. On the other hand, stereophotogrammetry can be used to generate canopy height over large areas, and they have been applied to both aircraft and then satellite images. NASA's AIMS pipeline have been used to generate um, canopy height information or the DEMs. And then the AIMS pipeline is a stereophotogrammetric pipeline. However, most of the applications are focused on urban or forest areas. Recently, Bush and Italy modified the AIMS pipeline to generate DEMs over mountainous areas. In addition to the stereophotogrammetric workflow, high-resolution satellites such as SkySat can provide image that can be used to feed AIMS pipeline. SkySat has a global reach with stereo capabilities and currently has 21 satellites in the constellation, and they provide multispectral data at 0.81 meter resolution with almost sub-daily revisits. And Christian Itel use SkySat and the modify aims to generate canopy height information. However, the problem here is agricultural landscape is fundamentally different and then present different challenges. And the flat terrain with limited topographic relief makes it challenging, as well as the homogeneous nature of crops, of their texture, and then the temporal variability that characterizes agricultural landscape. Then in most cases, the NASA's generic pipeline, AIMS pipeline, has not been explored for agricultural areas. So the aim of this study is to generate high-resolution canopy height information using SkySat Stereopair, and objectives include to assess the accuracies of SkySat AIMS pipeline of agricultural area, and also to estimate um, crop canopy height from two different dates. One of the image captured before the season and one in the season. So the study area for this work was the Driscoll, which is in the coastal bend area, and cross-grown in this area, including corn and then sorghum. So for the data set, we acquired pre-season stereo image, in-season stereo image in July, and we also used the 3-depth DEM for alignment and accuracy assessment, and also created validation point over croplands, trees area, and then woods. So for the method, we use the generic AIMS pipeline. So from the data acquisition to pre-processing, which included radiometric correction, RPC refinement, and then image pair selection. And then we go to the processing, the process itself, which included the stereo correlation, and then the alignment and georeferencing, and then move on to the post-processing, including smoothing, filtering, and then merging, and then validation analysis, and the final DSN and the DTN comes out. And then from there, we calculated the canopy height model. I wish to stress that for this particular study, we use only the 4 nadir image, as opposed to 4 nadir and then after data collection. For accuracy metrics, we use mean error, mean absolute error, root mean square error, and then the normalized median absolute deviation, which is widely used in DEM accuracy assessment. And this metric is robust compared to root mean square error. And then we assess the accuracies over three features: woods, trees, and then crops. So the first result is the generated surface dataset for the tree depth. That's on the left. You can see that it's the pure DTM with all the features cropped out. However, with the SkySat DSM for April, we can see the various features on the DSM, and then we can also similarly see that of the July, and features such as the riverine area and then the forest of the tree area is visible in both the DSMs generated. When it comes to the accuracy assessment, that's over the woods. What happened is we assess the accuracy of the generated DSM versus the ground truth, which is the tree depth data set. And focusing on the NMAD, we can see the error is actually a sub-meter error around 0.68 meters. And that's for the April image. We had also 1.5 meter NMAD for the July image. So between the two images, it just showed that the April image was more consistent, had fewer errors compared to the July image or DSM. The accuracy assessment over trees also showed a similar pattern. The NMAD for the April was still sub-meter 0.98. However, the NMAD for the July image was still 1.58. So it just showed that the NMAD, the July image or data set or DSM had some inconsistencies or had higher errors, I should say, between the two data sets or DSM generated. However, I have to stress that both the 0.9 and the 1.5 are highly comparable to the result from Bushnell et al. Because in Bushnell et al., it reported the accuracies of between 1 to 2 meter NMAD. So our result is highly comparable to the result from Bushnell et al. I think the main problem has to do with estimating or generating the CHM. We generated the CHM by subtracting the April image from April DSM from the July DSM. And we also apply filtering because the area during the July 2025, most of the crops that were left on the ground were just cotton. And these crops were between 0 to 2 meters. So we apply a filtering of 0 to 2 meters to the CHM that we generated. And it did happen to heavily filter out a lot of the values. This is to show that there are outliers or values that most of the values lied outside the 0.2 meter range. Okay, so at the end of the day, it just show that the workflow struggles to estimate or generate DSM for very low crop or crops or features that has shorter heights, such as cotton. Okay, so this is one thing that we realize with the current workflow, which we intend to modify. So in the next step, we would like to utilize dense matching approach from Bushnell et al. Because the current aims rely on shift algorithm for the stereo matching, okay? But the dense feature matching from Bushnell et al. Uses the different approach. So that's one thing that we want to implement. The second thing we want to implement is rather work over crops that grow a bit higher than cotton, such as corn. Okay, mostly corn is able to go to 2.5 or even 3 meters. So that's the second thing that I want to do. And then third, we also want to use four nadir and then four after, and then after nadir images. So all the three things we want to use all the three things to do the stereo photogrammetric approach, and then see how best that can go. Hopefully we'll be able to obtain or be able to get a CHM that is well represented of the 2 meter height. Okay, so in conclusion, I would say that we now have AIMS SkySat workflow over agricultural area, and it was able to generate two DSMs, which one of them we use as a DTM and the other one we use as a DSM. However, I need to stress that this workflow struggled over low crops with low heights. On the other hand, the results achieved in this study is not out of place, and it is well comparable to result by Bushan et al. And it just shows that we will need refinement in order to move a bit further or a step ahead from higher crops to a very low height crops, which usually most studies have not tested. So to this then I bring my presentation to an end, and I say thank you.